Hi, this is Mrs. Basin, and in this screencast we're going to talk about molecular formulas. So in the last screencast that you watched, we talked about the difference between empirical formulas and molecular formulas. So an empirical formula was the lowest whole number ratio, and the molecular formula is the actual numbers of elements in a compound. And then we looked at the difference between them, and we talked about how sometimes the empirical formula and the molecular formula are actually the same thing. So if you have the empirical formula, which you already know how to do, what we're going to talk about now is how to get the molecular formula. So when you look at the molecular formula, it's always an integer multiple of the empirical formula. So in order to figure out what this number is, you have to know the molar mass of a compound. So that's something that would be given in the problem that you're trying to solve. So if you look in the center of the slide here, it says to do this, the empirical formula times n, which is this integer, gives you the molecular formula. So to find n, what we have to do is take the molar mass, which is what would be given in the formula, or in the problem, and then the empirical formula mass, or the formula mass, is basically the mass of all the elements in the compound, in the empirical formula for that particular compound. So molar mass again would be given, and then the empirical formula mass, you just add up all the elements in the empirical formula. Okay, so we're going to do two examples here. So our first example is a very simple one. So this one says, a white powder is analyzed and found to have an empirical formula of P2O5. So they've already given you the empirical formula. So for this one, you wouldn't have to do the empirical formula part first. So they already told us that our formula is P2O5. So what we need is the molecular formula. So to find the molecular formula, we have to find what this value of n is. So again, n is equal to the molar mass over the formula mass. Okay, so the molar mass they gave us up here, so that's our molar mass. The formula mass, we're just going to add up P2O5, and that'll give us the formula mass. So if I add up P2O5, the formula mass, and those numbers again just come from the periodic table, I'm going to take 2 times phosphorus plus 5 times oxygen. That gives me 141.94 grams per mole. And then up here, they give me the molar mass, which is 238. So now all I have to do is plug that in. So molar mass again is 283.88 divided by 141.94. So then when I divide that, that comes out to be 2. So that means my n value is 2. So now all I have to do is multiply my subscripts by 2. So my molecular formula then is just P4O10. So that's the easiest version of all of these. The other way you might see these problems is sometimes you'll have to do the empirical formula first. So here's a practice problem. I would suggest stopping this and going through and working through the empirical formula first, and if you're good with molecular, go ahead and try that, and then come back and check. Okay, so our practice problem says we have a compound with a molecular mass, or we could also think of that as molar mass, of 74.1 grams per mole, and it tells us it has 64.8% carbon, 13.5% hydrogen, 21.7% oxygen. So just like we've done the empirical formula problems in the past, I'm going to make a list of all my elements present. Since I have these given in percents, I'm going to assume 100% or 100 grams. So I have 64.8 grams of carbon, 13.8 grams of hydrogen, 21.7 grams of oxygen. So then my next step is to convert that to moles, because again, to find my empirical formula, I'm looking for the lowest whole number ratio. So that's 12.01 grams. Again, that number comes from the periodic table. And this is just a review of what we did in the last screencast. So this first step, all we're doing here is finding the empirical formula. Okay, so when I calculate that out, for carbon, I get 5.396 moles. Hydrogen, 13.366 moles. And oxygen, 1.356 moles. Then again, at this step, now we're going to divide by the smallest because we're looking for that lowest whole number ratio. So oxygen is my smallest, so I'm going to divide everything by 1.356. That gives me 1. That gives me 9.9, which I can round to 10. And then for carbon, that gives me 3.98, which I can round to 4. So then my empirical formula turns out to be C4, H10, O. Now since I'm looking for the molecular formula, what I also need to find is my N value. So N, again, is molar mass or molecular mass divided by formula mass. Okay, so my molar mass or molecular mass is this number here, and then my formula mass comes from all of those elements added up. So again, to solve for N, my molar mass was given, so that's 74.1 grams per mole. And then if I add up 4 C's plus 10 H's plus O, I also get 74.1. And again, to get that, I took carbon times 4 plus hydrogen times 10 plus oxygen. That's where that 74.1 came from. So that's my formula mass. I'm going to divide by that, 74.1. So in this case, my N value is 1. So that tells me that my molecular formula is going to be the same as my empirical formula. So my final answer here, which I'm kind of out of room, but my final answer then would just be C4, H10, O. So this is one of those cases where your molecular formula and your empirical formula are the same.